Now that we have trained an MNIST model, we're gonna use this model to classify images. Okay, so here I just want to show you how you can close this notebook. If I can already close it here, and if I go back here, I can see that this notebook is the icon is green. It means that it's still running. So I can either go to running and shut it down here, or from here I can check the box in front of it and shut it down. Now we're gonna run model string. So if I go to running MNIST, so as I told you, the notebooks are always organized the same way. So I'm gonna first load all the packages that we need to run MNIST. Then I'm gonna run the parameter panel, and in that case, we need to define the directory where we have the images we want to process, which is, oops, sorry, I'm gonna do it again. That's in test. Then I need to select the input classifier. So here you see we have the different models we trained, and we tried 4 different values. So we saw that the one with a learning rate of 1 and 0.01 completely diverged. The one with 1 E-6 was not great. This one showed the best performance, at least just based on the curves. So if I select this one, now you see as this is a file, it appears in a yellow-orange color. And finally, I need to define in which directory I want to put my results. So here I don't have any directory, so I'm going to create one. If I go back to my folder here, test, create before. Yeah, it's going to be better. Though you can define it where wherever you want. And we're going to have 2 different kind of results, but I'm going to select one for now. Okay? So if I go back here, data sets, now I have a results folder. I can select it. So we have 3 channels, 2 classes, and the imaging field was 256 by 256. Now I go back to my images, the larger. If I again, we're fetching here, that's 2048 by 1536, both of them. So as I train a model with an imaging field for the images that is 256 by 256, what the algorithm is going to do is that it's going to time this image with 256 by 256 image patches, and then process each single patch. So you see there's this box. We're gonna look at it. I'm gonna change it next one. So first I'm gonna run with all these tools. So it takes a little bit more time first image because it loads all the weights for the model, and then it processes second image, and that's down. So now if I go back here, if I go to results, I have actually CSV files. If I open the first one, this is for the first image. I know it's the normal image. In that case, I have, this is the score for the first class. This is the score for the second class. So 0.35 or 0.64. So it's more likely to be the second class. The problem is that the second class is adenocarcinoma. The first class is normal. So it didn't work in the first one. For the second image, which was adenocarcinoma, the score is higher for second class. So that gives the right prediction. Now, if I just want the scores, I can, if I just want to have the scores for each class, this is what I can get. If I want to have image scores, I can check this box and run it again. And in that case, it's going to give me images with the different scores. And I'm going to open them so you have a better idea of what's going on. So that's for the normal. And I have an image with two different stacks. The first one is for class 1, second one is for class 2. So when it's dark for one class, it's obviously bright for the other class, and we have the scores. For example, it's 0.07 for class 1, this first image batch, and 0.93 for the second one. So, of course, it's scores, so you should have some of your scores going to be equal to 1. Now, this corresponds to my normal image, this one, that has been tied in small patches, so this corresponds to this point. And according to the model we trained, it found that this small patch has a higher score to be adenocarcinoma than normal. And so on. So the ones that are in the background seem to have a higher score for adenocarcinoma than for normal. This one was particularly high for normal. The score I obtained in this file is actually average score across my image. So obviously it's weighted by the size of the image patches, because as I can't have 256 by 256 image patches only, so you have some that are smaller here. So these ones may have a lower weight than the other ones. But basically, this corresponds to the average score for each of your class. And so clearly for normal image didn't work. For the adenocarcinoma overall, it worked. It's interesting because here, as we compute a score for each sub-image, we can see which sub-images gave a very high score for adenocarcinoma. And here, it's clearly, most of it, except this part. So this part didn't look that adenocarcinoma, but everything else looked adenocarcinoma. So that's a good thing here, that as we saw, it completely failed to predict normal tissue for this image. So we're going to see that now if we do some transfer learning with a model that's being trained on the ImageNet data set, make that prediction.